CPU bus. Okay. So CPU is nothing but microprocessor. It has only registers. It perform only calculations. Perform only arithmetic calculations like addition, subtraction. So the CPU performs the operation in terms of microseconds. That's the 10 to the power of -6. So it performs only fetch, decode, and execute. Okay. So as I emphasize here, this microprocessor does not have any peripherals. That's why we are going to be integrate these peripherals externally. Okay. So you have to connect these peripherals externally to the microprocessor. So in simple words, the microprocessor we can say is a CPU, central processing unit, or it's a brain of computer. So here you can see the three different types of line. First line indicate address bus, and second one is data bus, and third one is control bus. Okay. This address bus is unidirectional. Uni means only one direction from microprocessor to memory. Okay. Then second one is data bus. It can operate on both sides. That is read and write operations. Here you can see RAM is responsible for read and write. So this one is read only. Okay, that's why we used to say ROM, read only memory. This is a random access only, so it can perform read and write. So here we have arrow control bus. So this will be a read and this will be a write. Because this RAM acts as a mediator between ROM and microprocessor. Okay. As I emphasized earlier, RAM is a data memory, ROM is a program memory. We used to write the code in the ROM. Okay, it's on-time program. All the code source code will be written in ROM. That's called firmware. Used to call it the firmware in software development. So here, between microprocessor and ROM, this acts as a mediator. Okay. As I said, microprocessor perform three operations. One is fetch, decode, execute. Execute. Okay. These three operations is done by this microprocessor. So these are the peripherals: RAM, ROM, I/O ports. Okay. So this control bus responsible for controlling the operation of this microprocessor. Whether it want to be read, or it want to be write, or it want to be transmit, or it want to be receive. Okay. Or reset, interrupt. So these are the control signals. So I have given examples for this. So these are the few examples for buses. So in simple word, bus is a group of metallic wire. In school days, we used to study the computer subject, computer organization. The core will be a microprocessor. We have keyboard, we have display, we may have printers, then we may have memory, then DME. Okay. These peripherals are connected to bus only. These all the peripherals are integrated to the CPU by means of peripherals. Okay. That bus, it may be serial bus or parallel bus. Serial bus or parallel. According to today's topic, we are discussing only about serial bus. Serial bus means it has only few lines. For example, 2 to 5 wires. For example, you take pen drive. In a pen drive, you have a terminals of approximately 5 terminals, like positive supply. Pen drive is a female connector. So here you can see the 5 terminals. One is the supply, another is ground. One is data in, data out. Okay. Another one is up and down. These are the 5 serial wires that is integrated to the memory. So this is a row. This one is a row. Plastic row. Okay. Similarly, if you connect a keyboard or mouse, it's a serial bus. So there you can see the parallel. The parallel port has more than 8 pins. Okay, like printers, dot matrix printers. Then that is we can say simple example like CNC machine, computer numeric control machines, DNC machine. then your 3D printers, those things are connected to the parallel wires. Why means the wire, it will be parallel send the data. So in this case, they use different types of mechanisms using this serial communication protocol. You are going to send and receive. Okay. There will be certain important points that we consider. Each and every serial communication, the data rate will be different, size will be different. So for example, this pen drive transfer the data rate depend upon the size of the bus. Depend upon the size of the bus. For example, you take 2 to the power of n ratio. 2 to the power of 16 means it can transfer up to 65,536. Okay. So normally the microprocessor has a different range. This address bus means it can carry 16 bit. Okay. Data bus means 8 bit. Control bus means 8 bit. Okay. Currently in your mobile, all the buses are 32 bit wide. Currently you are using mobile phone now. All the bus, address bus, data bus, control bus, all are 32 bit wide. Okay. So it can transfer large amount of data at the same time. Okay. So these are the points you have to consider while transferring the data from buses. First point is bus arbitration. It means, for example, in your system you are connecting pen drive. How many pen drive you can connect? 2, 3. Then anything else? How many port it will be in computer? Your laptop? 2. If you connect the hub, okay. If you extend now, how much you can extend? You are connecting the Arduino board now. Arduino board is connected in COM port 3. It shows, it gives the address now. Through this address, the microprocessor gives the address for the device what you have connected. Okay. Similarly, 256 IO device you can connect in a one port. In one port, if you split with the hub now, you can connect 256 IOs you can connect. So in a PC, we have more than 4 USB ports. Okay. For that, the mediator will be DMA, direct memory access. The name is in place, direct memory access. You can access the memory directly from the hard disk. Okay. First thing you have to request from the CPU. Once CPU gives the granted from your pen drive to hard disk, you can send and receive the data. CPU will not interrupt. First thing you have to request. That's called DMA request. Another one is ISR, interrupt service routine. Meanwhile, you are transferring the data. Okay, you are connecting another pen drive. At the time microprocessor what will do, it give another address location, COM port 7. That's called interrupt service routine. Come back. So these 4 points are very important. First point is bus arbitration, means how many IOs are connected to the device. Okay. So nearly 256 can be connected to your computer. Second one is error detection and correction. While you are sending the data from your computer to your printer, okay, your printer is not ready now, the computer that shows the pop-up, the device is not ready. It's not switched on. Okay, like this, the pop-up will be. So that will be error detect. Then once you switch on, the send data will be sent back. Okay. For example, in your you have computer, you have printers. Okay, I have sent a number of pages to print. Okay. The printers has taken more than 5 pages, and 6th page gets stuck. Okay. At the time, what happened? The message, the control signal from printer to computer, print error. You are getting the acknowledgement. Then what you do, you reset or you will continue from the page. That's called error correction, error detection and correction. So there will be a code called parity check, parity, odd parity, even parity, data and then the receiver it will be even or odd. Okay, odd na 3, 5 on the mari. Even na 4, 6 on the mari. Data from transmitter to receiver. Another one is cyclic readiness check. Once the printer is ready, then only you can be able to give the print. So that's called error detection and correction for a serial bus. And the third one is bus width. There are different types of buses, like based on the size. Last class we discussed about SATA bus, serial, advanced, attached to it. So it can transfer GB of data. Okay. Another one is PC, peripheral component interconnector. Then FRC, flash ribbon cable. So these bus size will be varied based on bus width. Okay. So last one is bus speed. Okay. This determine data rate from source to destination. From your hard disk to the pen drive. That's the source hard disk, the pen drive is the destination. So you are copying the data now. Data will be in terms of bit per second, kilobits per second, or megabit per second, or gigabit per second. So these are the key things with this device.